Hashtag how blockchain technology works, a deep dive. Hashtag BlockVault Daily. Imagine sending money directly to someone on the other side of the world, no bank, no middleman, no waiting 3 to 5 business days for clearance. The transaction settles in minutes, it's permanently recorded, and nobody can alter or delete it. That is not a futuristic fantasy. That is blockchain technology working exactly as designed, right now, today. But how does it actually work under the hood? What makes it so secure, so transparent, and so fundamentally different from every system that came before it? Today, we are going deep, technically deep, into the architecture, the mechanics, and the real-world implications of blockchain. By the end of this video, you will understand this technology better than 90% of people talking about it online. Hashtag background. The problem blockchain was built to solve. Before we explain how blockchain works, we need to understand why it was invented in the first place. The core problem is called the double spend problem. In digital systems, copying information is trivially easy. If you send someone a photo, you still have the photo. But money cannot work that way. You cannot spend the same dollar twice. Traditional financial systems solve this by relying on centralized intermediaries, banks, payment processors, governments, entities that maintain official ledgers and validate that you actually have the funds you are trying to spend. This system works, but it has serious drawbacks. It requires trust in institutions that have historically failed, been hacked, or acted against the interests of their users. It creates single points of failure. It excludes roughly 1.4 billion unbanked adults worldwide who have no access to these intermediaries. And it demands fees, delays, and surveillance as the cost of participation. In 2008, an anonymous individual or group using the name Satoshi Nakamoto published a 9-page white paper titled Bitcoin, a peer-to-peer electronic cash system. The genius of this document was not Bitcoin itself, it was the underlying mechanism that made Bitcoin possible. That mechanism was blockchain, a distributed, decentralized ledger that solves the double spend problem without requiring any central authority whatsoever. Hashtag what is a blockchain, exactly? At its most fundamental level, a blockchain is a database. But it is a very specific kind of database with 3 defining characteristics that make it revolutionary. It is distributed, meaning thousands of computers around the world hold identical copies of it simultaneously. It is append-only, meaning you can only add new data, you can never delete or modify what already exists. And it is cryptographically linked, meaning each new entry is mathematically connected to the one before it, making tampering extraordinarily difficult and immediately detectable. The data in this database is organized into blocks. Each block contains 3 essential components. First, a set of transaction data. For Bitcoin, this might be several thousand individual transfers recorded together. Second, a timestamp marking exactly when the block was created. Third, and most critically, a cryptographic hash of the previous block. That third element is the chain. A hash is a mathematical fingerprint, a fixed-length string of characters generated by running data through a cryptographic algorithm. Bitcoin uses SHA-256, which takes any input, regardless of size, and produces a unique 64-character output. Change even one character in the input and the output changes completely. This property means that if anyone tampers with data in block number 400, the hash of that block changes, which breaks its connection to block 401, which breaks its connection to block 402, and the corruption cascades forward through the entire chain. This is immediately visible to every node in the network. Hashtag how transactions actually work. Let us walk through a real Bitcoin transaction step by step to see how all of this functions in practice. Say you want to send half a Bitcoin to a friend. You initiate the transaction using your wallet software, which cryptographically signs the transaction using your private key. This digital signature proves you authorized the transaction without ever revealing your private key itself, a concept called public key cryptography. Your signed transaction is broadcast to the Bitcoin network, where it enters a waiting area called the mempool, short for memory pool. This is where unconfirmed transactions sit, waiting to be picked up and included in a block. At any given moment, the Bitcoin mempool can contain tens of thousands of pending transactions. Now the miners enter the picture. Mining is the process by which new blocks are created and transactions are confirmed. Miners collect transactions from the mempool, bundle them together, and then compete to solve an extraordinarily difficult mathematical puzzle. This puzzle is called proof of work. The miner must find a specific number, called a nonce, that when combined with the block's data and processed through SHA-256, produces a hash that starts with a required number of zeros. This sounds straightforward, but there is no shortcut. Miners must try billions of combinations per second, burning enormous amounts of computational energy in the process. The Bitcoin network currently processes over 500 exahashes per second collectively, that is 500 quintillion calculations every single second. The first miner to find the correct nonce broadcasts their completed block to the network, other nodes verify the solution is correct, and the block is added to the chain. The winning miner receives a block reward currently set at 3.125 Bitcoin following the April 2024 halving event, plus all transaction fees from included transactions. ##### Decentralization and consensus mechanisms. Here is where the real security of blockchain emerges. There is no central server storing the official version of the ledger. Instead, thousands of nodes, individual computers running the Bitcoin software, each maintain a complete copy of the entire blockchain. When a new block is added, every node updates its own copy simultaneously. The network reaches agreement through a process called consensus. If someone wanted to alter historical transaction data, say, to reverse a payment they made, they would need to redo the proof of work for the tampered block and every block that came after it, all while the rest of the network continues adding new blocks at full speed. To successfully execute this attack, they would need to control more than 50% of the entire network's mining power. This is called a 51% attack, and on Bitcoin's network, it would require billions of dollars in specialized hardware and electricity costs. The economics make it essentially impossible. Not all blockchains use proof of work, however. Ethereum, the second largest blockchain by market capitalization, completed what it called the merge in September 2022, transitioning from proof of work to proof of stake. In this model, validators lock up or stake their own Ethereum as collateral to earn the right to validate transactions. Ethereum currently requires 32 ETH to become a validator. If a validator attempts to cheat the system, their staked ETH is destroyed in a process called slashing. This system uses roughly 99.9% less energy than proof of work while maintaining strong security guarantees. #smart contracts. Blockchain beyond currency. Blockchain technology became exponentially more powerful when developers realized it could store and execute code, not just transaction data. Ethereum pioneered this concept through smart contracts, self-executing programs stored on the blockchain that automatically carry out predefined actions when specific conditions are met. Consider a simple example. A smart contract can hold funds in escrow and release them automatically when a delivery is confirmed, when a vote reaches a threshold, or when a certain date arrives. No lawyer, no judge, no intermediary required. The code executes exactly as written, transparently, and permanently. The smart contract platform has given birth to an entirely new ecosystem: decentralized finance protocols managing over $40 billion in locked assets, non-fungible token marketplaces, decentralized autonomous organizations, and cross-border supply chain management systems used by corporations including Walmart and Maersk. ## Limitations and challenges worth understanding. Honest education requires acknowledging where blockchain technology still struggles. Scalability remains a significant challenge. Bitcoin can process approximately 7 transactions per second. Visa, by comparison, handles an average of roughly 1,700 transactions per second and can theoretically scale to 24,000.